The next two rational equations are very similar to what we've just done, but we have to look at these a little bit closer and see if there's any way that we can make it a little bit easier on ourselves. Because if we have three fractions, they look messy, I would say clear them out, get rid of fractions we don't like them. Problem is, everybody's going to say, okay, we're going to multiply by x minus 6 to clear the first. We're going to multiply by x minus 2 to clear the second. And then we're going to multiply by x squared minus 8x plus 12 to clear the third. But if you look at it a little bit closer, this is a quadratic, I would be thinking about factoring. And if we're going to factor this, we're going to get x minus 6, x minus 2. So really, I have not changed anything. I just rewrote the denominator of that third fraction. And if you look, and we go through and we're going to say, okay, we've got division by x minus 6. To clear that out, we're going to multiply by x minus 6. We've got division by x minus 2. We're going to multiply by x minus 2. And now, you have to keep the x minus 2. Some people want to just put the negative 2 because they see an x here. That's x minus 6. That's one value, so we can't separate those individually. Then we have, on our third fraction, division by x minus 6 and x minus 2. Well, over here, we're already multiplying by x minus 6, so that's going to clear the first term. And we're multiplying by x minus 2, that's going to clear. So these two terms are the only things we're going to multiply through to get rid of all three fractions. So you do not have to repeat. So when I push that first through, x minus 6 cancels, the 1 from the top stays, and the x minus 2 gets carried along. Plus, I'm going to take this to the second fraction. X minus 2 will cancel. I had an x in the numerator and an x minus 6 that did not cancel. Then, if I multiply to the third, x minus 6, x minus 2's cancel out of both, so all I'm left with is 4, so that makes it a little bit easier. Now I have to simplify, so we have x minus 2 plus x squared minus 6x equals 4. As soon as I see that I have an x squared that's not canceling, I think it's a quadratic. I know it's a quadratic. And then that means I have to get it equal to 0 so that it will factor. So I'm going to bring the x squared to the front. I've got 1x minus 6x, so I've got negative 5x. I'm going to subtract the 4 over, so I end up with minus 6. Now it's factorable, because remember, we're trying to solve it for x. So if I factor this, I'm going to say x minus 6, x plus 1, equal to 0. So what this is telling me is that I'm looking for what value I can plug in for x is going to make that equal 0. If you're not sure, set it equal to 0. But we know that x equals 6 and negative 1. Now just go back and see if these do in fact work. So if I plug in a 6, I can tell right here, if I have 1 over 6 minus 6, that's 1 over 0. I can never divide by 0. So 6 is not an answer. Go back and double check. Are any of these values going to give you zeros in the denominator by plugging in negative 1? No, we're good there. We're good, and we're good. So my only answer is negative 1. If we look down here, there's a lot of different ways that we can solve this. I'll show you two of them. One that I think most people will pick is to combine my like terms. So we have 1 over x and we have negative 8 over x. We have a common denominator. So I'm going to subtract 1 over x from both sides. That leaves me 5 equal to negative 9 over x. Now it's a pretty simple problem. We would multiply by x. It gives me 5x equals negative 9. Divide by 5. So x is negative 9 over 5.